Okay, today we're going to talk about in this video IV pump and IV via gravity. So when we are talking about IV pumps, when you get questions regarding infusion rate, flow rate, drop rate, if it says the word IV pump, the answer is always in milliliters an hour. The other option is IV gravity, and this is the one where we have to use drop factor. In your problems, the word pump will not be in the question, and it will have a drop factor. So these drop factors basically mean if it says 10, the drop factor is 10, that means it takes 10 drops to make 1 milliliter. If it says the drop factor is 20, that means it takes 20 drops to make 1 milliliter. So I wanted to just review those two things. So again, if you are answering a question and it says that they want the flow rate, the infusion rate through an IV pump or via an IV pump, your answer, your wanted, will always be milliliters per hour. So let's look at this IV question. The MD orders 1,000 milliliters of half normal saline to infuse over 6 hours via pump. What is the infusion rate, or say, what is the flow rate? So how do we solve for these type of problems? Well, when you're looking at infusion problems or IV fluid problems, you have to be able to pick out what you need from the question. So the doctor orders 1,000 milliliters to be infused over 6 hours, and it's via pump. So the first thing you should be thinking is, I'm solving for what? It says pump, and it wants the infusion rate or flow rate. So you are solving for milliliters an hour. So what is the doctor's order? He's ordering 1,000 milliliters in 6 hours. So when we look and we set up our problems, we always want to get rid of the unwanted. But as you can see, we want milliliters in the numerator and hours in the denominator, and we already have that. So this is basically dividing 6 into 1,000. So when we divide 6 into 1,000, we get an answer of 166.66. Remembering our rounding rules for IV fluids and anything greater than 10, so 166.6, the 6 is greater than 5. So the answer is 167 milliliters an hour, and that's what you will set your IV pump at. So this question says, the physician orders 1,000 milliliters of D5W with 40 milliequivalents of potassium, and they want that to infuse over 12 hours. What is the infusion rate? Or it could say, what is the flow rate? So this case, again, it doesn't say the word pump, but it doesn't offer a drop factor either. So he's simply asking you to give 1,000 milliliters of a fluid, which happens to have this medication inside of it. But we're not worried about that. We're not solving for strength of a medicine or strength or dose of a medicine. We're simply solving for infusion rate. And because there's no drop factor, it doesn't say pump, but my only option is to solve for milliliters an hour. And it's 1,000 milliliters, because remember, I need milliliters in my numerator and hours in my denominator. I have it just from what's in the question. So again, now it's just math. 12 divided into 1,000 is 83.33. And that is rounded to 83 milliliters an hour. So let's look at this question. The doctor orders 500 milliliters of 0.9 normal saline or isotonic fluid, and he wants that run in 1 hour. The drop factor is 10. What will you set the IV pump infusion rate at? So right away, my question says the word pump. When it says the word pump, I do not use the drop factor, because whenever I'm using an IV pump, I'm always solving for milliliters an hour. So I don't need that drop factor. My volume is, he wants 500 milliliters, and he wants that run in 1 hour. I have milliliters in my numerator, hour in my denominator. So now it's just math. 1 divided into 500. We're going to set that pump to run at 500 milliliters an hour. Now, some of you are thinking, wait, isn't that a lot of fluid? Yes, it is. But some patients who are critically ill may need a fluid bolus. And that's what his order was, give a bolus. So to solve for this, we're always looking for milliliters an hour. If it says the word IV pump or pump in the question, we do not use drop factor. So here's another question. What is the infusion rate for an IV ordered 1 liter per day via IV pump? Drop factor 10. Now you can pause it here and try to solve on your own and just restart it. But how do we solve this problem? They ordered 1 liter per day. The word pump is in my question. I do not need drop factor. So 1 liter is what? 1,000 milliliters, because I'm solving for what? I have pump. I'm solving for milliliters an hour. 1,000 milliliters per day. Well, how many hours are in a day? 24 hours. I have milliliters in my numerator, hours in my denominator. I'm all set. Now it's just math. So 24 divided into 1,000 gives me 41.66, and I round that to 42 milliliters an hour, and that's all I write in my answer line. Here's another problem. A patient is to receive 500 milligrams of a medication, IV Soluset, in 50 milliliters of D5W over 45 minutes. What is the flow rate you will set on the IV pump? So right away you see it says IV pump, and it's asking you, what is the flow rate? When we solve for IV pumps, we're always solving for milliliters an hour. All right, so what is my volume? 50 milliliters. And what is my time? It's 45 minutes. So again, we get rid of our unwanted. So how do I get minutes out of there? And how do I come to hours? Well, I know that there are 60 minutes in 1 hour. I'm able to cancel out my minutes, and now I'm left with milliliters in my numerator and hour in my denominator. And now you know, it's just math. So 50 times 60 is 3,000, and 45 times 1 is 45. 45 divided into 3,000 is 66.66. Oops. And I follow my rounding rules. So I'm going to set my pump at 67 milliliters an hour. So that's why we made you remember those abbreviations. So IV Soluset, IV Piggyback, these are smaller infusion bags. And often we'll run medications with just 50 milliliters or 100 milliliters. And again, we're not worried about the strength because the question is not asking us dose or strength. So when we're solving for infusion rates, we're looking at that volume, which is 50 milliliters, and time, which is 45 minutes. So let's look at this problem. A patient is to receive 500 milliliters to infuse over 4 hours. The drop factor is 20 drops per milliliter. What is the flow rate? So here's a problem. It's asking us flow rate again. But what is missing from this question? Well, what's missing is the word pump. Because the word pump is not there and it's offering us a drop factor, now is the time we have to use it. Because there's no word pump, now we have to use the drop factor. So how do we solve when we're using drop factors? Well, we still start with the volume over the time. 500 milliliters over 4 hours. Because that's what the doctor wants. That's the order. He wants you to give 500 milliliters over 4 hours. But what am I solving for? What is my wanted? Well, remember, when we're using gravity and there's no pump, we have to literally count drops every minute. So we have to solve for drops per minute. So our wanted is drops per minute because there's no pump available. So I have milliliters to get rid of, an hour to get rid of, because we're always getting rid of the unwanted. to get to our wanted. I need drops in my numerator and minutes in my denominator. So how do I get rid of the milliliters? Well, I use what's in my problem. There's 20 drops per milliliter when we're using the drop factor. That gets rid of my milliliters, and that has given me drops in my numerator. But now how do I get hours to minutes? Well, 1 hour is 60 minutes. That gets rid of my hours, and I'm left with minutes in my denominator. And now you know, it's just math. So 500 times 20 is 10,000. And 4 hours times 60 is 240. And when I divide 240 into 10,000, it gives me 41.66. I can't split a drop. So I'm going to round that up because 6 is greater than 5. So I'm going to count 42 drops per minute to give what is ordered, 500 milliliters per hour. So based on that tubing that has a drop factor of 20 drops per milliliter, I'm able to count for 1 minute 42 drops, and that will give me 500 milliliters in 4 hours. Let's look at this one. What is the drip rate for an IV ordered? 1 liter per day with a drop factor of 8. So if you want to pause it here, go for it and try to figure this out on your own. But when I'm looking at this question, what is not in this question? And you should all be saying the word pump. So when the word pump is missing, that means we do not have a machine to infuse our IV fluids. So there's no word pump, but it's offering me a drop factor of 8. And remember, when we're saying drop factor of 8, it means it takes 8 drops to make 1 milliliter. So 1 liter per day. 1 liter per day is 1,000 milliliters, and a day is 24 hours. I'm solving for what? It's gravity, so I'm solving for drops per minute. So how do I get rid of my hours and get minutes? 1 hour is 60 minutes. That gets rid of my hours. How do I get rid of milliliters and get drops in my numerator? I use my drop factor. 8 drops per milliliter. Oops, sorry. I just crossed out the wrong one. That gets rid of my milliliters. So now it's just math. So 1,000 times 8 is 8,000. And 60 times 24 is 1440. When I divide 1440 into 8,000, it gives me 5.55. I can't split a drop, so I have to round up to a whole number when it comes to drops. And this would give me 6 drops per minute. What's the infusion rate for an IV ordered? 1 liter per day, 1 liter per day with a drop factor of 20. No word pump, pump is missing, and I have a drop factor, so I'm solving for what? Drops per minute. So I start my problem with what is the ordered volume and the time. 1 liter is 1,000 milliliters. A day is 24 hours. I have to get rid of milliliters and hours. So I can start any way I want. I can use my 20 drops. My drop factor is 20. So that means there's 20 drops per milliliter. So I can use that in my problem. Oops. Fun time today. 20 drops per milliliter. That gets rid of milliliter. I have my drops in my numerator. That's perfect. How do I get hours to minute? 1 hour is 60 minutes. That gets rid of hour, and now it's just math. So 1,000 times 20 is 20,000. And 60 times 240 is 1440. When I divide 1440 into 20,000, it gives me 13.88. I can't split a drop, so I round it to 14 drops a minute. And that's what you write on your answer line. Here's another problem. This is why you had to memorize what microdrip is. So if you want to pause it here and give it a try, go for it. So it's saying 500 milliliters to be given via microdrip over an 8-hour period. So if you had memorized what microdrip is 60 drops per milliliter. And I have to give 500 milliliters over 8 hours. So the word pump is not my question, and I have a drop factor. I'm solving for drops per minute. My volume order, 500 milliliters, and the time frame, 8 hours, volume over time. And now it's the same process. How do I get rid of milliliters? I use my drop factor. That's 60 drops per milliliter. Get rid of my hour. 1 hour is 60 minutes. Check out my problem. I've gotten rid of my hours. I've gotten rid of my milliliters. I have drops per minute, exactly what I need. So now it's just math. So 500 times 60 times 1 is 30,000. And 8 times 60 is 480. When I divide 480 into 30,000, it gives me 62.5. I can't split a drop, so I'm going to give 63 drops. I'm going to count that out for 1 full minute. And that's my answer. All right, here's another problem. You can pause it here if you want to give it a try. So the doctor orders 1,500. I'm going to calculate the infusion rate for 1,500 milliliters of IV fluid. The time frame is 24 hours. I have micro drip, which is 60 drops per milliliter. So no word pump. I have a drop factor. I'm solving for drops per minute. My volume order, 1,500 milliliters over a 24-hour period. Process is the same. Use my drop factor to get rid of my milliliters. And use 1 hour is 60 minutes. My conversion to get rid of hour. And now it's just math. So 1,500 times 60 is 90,000. And 24 times 60 is 1,440. When I divide this into 90,000, it gives me 62.5. I can't split a drop, so 63 drops per minute. And here's one, IV Soluset. Patients to receive 50 milligrams of a medication, IV Soluset, in 50 milliliters of normal saline over 30 minutes. The drop factor is 10. What is the flow rate? So again, what is missing? There's no pump available. So I have a tubing with a drop factor of 10, and that means there's 10 drops to make a milliliter. So when I look at my problem, I'm solving for drops per minute. Don't let these throw you off. This is a strength. We're not solving for strength. It didn't ask you strength of a medicine, dose of a medicine. It asked you flow rate. So I am not concerned about the strength of the medicine. What I am concerned is the volume. So I have to give 50 milliliters over 30 minutes. So if you know what your wanted is, I need drops in my numerator, minutes in my denominator. Well, if you look, I already have minutes in my denominator. So how do I get rid of milliliters and get drops in my numerator? I use the drop factor. 10 drops per milliliter. I cross off my milliliters. Now I have drops in my numerator, minutes in my denominator, and that is it. This problem is done. 50 times 10 is 500. 30 times 1 is 30. And when I divide 30 into 500, it gives me 16.66. I can't split a drop. So my answer is 17 drops per minute. So pause here if you want to try this problem on your own. Patient is receiving IV at 125 milliliters per hour. The drop factor is 10. Calculate the flow rate. So this is asking you a similar question, but in a different way. So what is available in my question? They're getting 125 milliliters, that's my volume, every hour. That's my time. The drop factor is 10, and they want to know the flow rate. Again, what's missing? There's no pump available. No word pump in my problem, and they gave me a drop factor. And a drop factor of 10 means 10 drops per milliliter. So I start my problem. I know I'm solving for drops per minute. So I'm getting 125 milliliters, that's my volume, over my time. Well, it's per hour, so it's per 1 hour. How do I get rid of my milliliters? I use my drop factor, 10 drops per milliliter. I have drops now in my numerator. How do I get rid of hour? 1 hour is 60 minutes. That gets rid of my hour. Now it's just math. So 125 times 10 is 1250. And 60 times 1 is 60. When I divide that into 125, it'll give me 20.83. And I can't split a drop, so 8 is greater than 5, so I'm going to round up. So my answer on my answer is 21 drops per minute.